Monomials, polynomials, degrees, and ordering terms. A monomial is a single-term expression that is a number, a variable, or the product of numbers and variables. Here are some examples of monomials. 7, -3, 127, x to the third power, 1/8, the square root of 7. Here are some single variable examples: x, y, z, a, b, or c. Or the product of a constant and variables: xy to the third, 2x squared yz, 0.5a squared, or 1/3 r. Variables raised to a power have exponents that are non-negative integers. Anything except 0 raised to the 0 power is 1. Any constant monomial can be written as the constant multiplied by a variable to the power of 0. For example, 6 can also be written as 6 times x to the 0 power, since x to the 0 power is 1. What is the exponent of the variable in the expression 5x? What is the exponent of the variable in the expression 5? Since 5x is equivalent to 5x to the first power, the exponent of the variable x is 1. Anything except 0 raised to the 0 power is 1. Therefore, 5 can be rewritten as 5 times x to the 0 power. The exponent of the variable in this case is 0. The degree of a monomial is the sum of the exponents of the variables that appear in it. The table gives several examples. The degree of x to the p power times y to the q power times z to the r power is p plus q plus r. So, for example, a polynomial of the 0th degree would be just a constant. Of the first degree, we would have -5x, or 4r, or 1/5 r. Any variable that's exponent is 1. The second degree, 2y squared, or -18z squared, or 2/3 bc. This counts because each of these has an exponent of 1, and you add them together. So that's how you get 2. The third degree, 3/8 ab squared, since a has an exponent of 1, and 1 plus 2 is 3. 2x squared y, or 9xyz, where all three of these have a 1 for the exponent, so therefore we get the third degree because we add them together. The fourth degree, 22c to the fourth, or -3/4 axz squared, because these have 1s as exponents. 1 plus 1 plus 2 is 4. The degree of a non-zero constant, such as 5 or 12, is 0 because x to the 0 power equals 1. Therefore, 5 equals 5 times x to the 0, and also 12 equals 12 times x to the 0. The constant 0 has no degree. The degree of 3x is 1 because the variable x has a degree of 1. The degree of -6x cubed y is 4 because x has a power of 3 and y has a power of 1. So the sum of the exponents is 3 plus 1, which is 4. The degree of 9 is 0 because a constant has a degree of 0. What are the degrees of the following monomials? 12x has a variable x to the power of 1, therefore it is 1. Remember, a constant out front does not have a degree. 9 by itself has a degree of 0. 6x cubed y to the fifth, we add the 3 and the 5 to get 8. -8xy, x has an exponent of 1 and so does y, so 1 plus 1 is 2. 15 is just a constant, so it has a degree of 0. And here we have -4 times x to the first times y to the fifth. We add the exponents and we get 6. Terms are mathematical expressions separated by addition or subtraction signs, not in parentheses. A polynomial is an expression that contains one or more terms. The terms of a polynomial are separated by addition or subtraction signs that are not inside parentheses. There are special names for polynomials with fewer than 4 terms. If it has one term, it's a monomial, so 5a squared, 4d cubed, x squared, or 8. If there are 2 terms, it's a binomial, c squared plus d, 8x cubed plus x squared, 8a cubed minus 2b squared, 4c minus mn cubed, and RT over 4 plus a to the fourth b over 15. If there's 3 terms, it's a trinomial. 7 plus b plus c squared, 8x plus 4y minus y cubed, m plus 4 minus p squared. Polynomials do have one or more terms made up of numbers, variables raised to non-negative integer exponents, and products of numbers and variables. They don't have one or more terms that include square roots of variables, negative exponents, fractional exponents, or variables in the denominators of any fractions. The degree of a polynomial is the same as that of the term with the greatest degree. For example, the degree of the polynomial 4x cubed y squared minus 6xy squared plus xy is found as follows. First, determine the power of each term. So 4x cubed y squared has a degree of 5. Negative 6x to the first y to the second has a degree of 3. And xy has a degree of 2. The highest degree is 5, therefore the degree of the polynomial is 5. Polynomials can either be labeled as the value of the degree, such as 0, 0th, 1, or first. They also have names as shown in the below chart. A polynomial of the degree 0 is a constant. A polynomial of degree first is linear. Second degree would be quadratic. The third degree would be cubic, and the fourth degree is quartic. Find the degree of the polynomial, then name it. All right, 3 is just a number, so it has a degree of 0. It's a constant monomial. 12c cubed plus c squared minus c plus 1 has 4 terms and a maximum degree of 3. So it is a cubic 4-term polynomial. AB has a degree of 2, and it's 1 term, so it's a quadratic monomial. 8s to the fourth t minus 9s squared t squared, well, this term has a degree of 5, and this one has one of 4, therefore it's a 5th degree polynomial, and there are 2 terms, so it is a binomial. 2 minus 7n, well, the greatest degree is 1, and it's 2 terms, so therefore it is a linear binomial. H to the fourth minus 8t has a degree of 4, and it has 2 terms, so it is binomial. So it is a quartic binomial. Here we have 3 terms, so it's a trinomial, and our highest degree is 4, because we have v squared y squared in there. So it's a quartic trinomial. The standard form of a polynomial is when terms are arranged in descending order of degree, from highest to lowest. Follow this process to put a polynomial in standard form. Identify the degree of each term. Arrange the terms so that the term with the highest degree comes first. Continue arranging terms in descending order of degree. In multivariable polynomials, order terms based on the powers of a specific variable. Consider this expression. Let's order the expression by powers of x. So here's x to the second, x to the first, x to the third, and x to the 0, right? You can think of it as x to the 0 because it doesn't even have an x there. Then we're going to order them by their terms by the powers of x. So first we're going to have x cubed. That one goes there. Then we have this term x squared, x to the first, and then x to the 0. The term y squared can be written as x to the 0 times y squared, therefore it has a power of 0. The power of the variable y is not used to order the terms. 5x cubed plus 2x squared minus x plus 7 is in standard form, as the terms are arranged from highest degree to lowest. The degree of x cubed is 3, the degree of x squared is 2, the degree of x is 1, and the degree of 7 is 0. Write the following polynomials in standard form. Alright, so we're going to order them from highest degree to lowest degree. So x to the 7th is the highest. Then we have x to the 5th, x to the 4th, x squared, x to the 1st, and x to the 0 power. All right, here we have x to the 9th is our highest degree. Then we have x to the 8th term. Don't forget to bring the negative signs with the terms when you're reorganizing them. We have x to the 6th, x to the 4th, x to the 3rd, x to the 1st, and x to the 0 power. Here we have x's and y's. So because y has the highest degree overall, let's start with the y's and then we'll do the x's. So we have negative 8y to the 5th, then we have 6y to the 3rd, and negative 3y squared. Then we're going to switch over and do the x's. So the x's in order, negative 9x squared, 2x, and then finally we have a constant of 4. Down here we have a's and b's. Because a to the 9th is the highest degree here, let's start with the a's and then we'll do the b's. So 5a to the 9th, we have negative 2a cubed, 2a squared, then we have negative 7a to the 0. It is just a constant. And then we're going to go to the b's. We have 9b squared, then we have negative b squared. Wait, those can be actually combined together. Those are like terms. This actually becomes 8b squared. And then we have plus b, so 8b squared for those two.